this problem. One is the cylindrical shape and the other one is the hemispherical dome. The metal is in the dome and costs 1.5 times as much as the concrete. That's a per unit area. And if the volume of the silo is 750 cubic meter, what are dimensions of the silo? As for the radius and the height of the cylindrical tower. Another key term, minimize the cost of the material. Assume the silo has no floor and no flat ceiling under the dome. So to draw the figures with the two different shapes involved, the first one is the body of the dome, the body of the silo, which is in the cylindrical shape. Okay, no base, right? No base. And the top part is in the hemispherical, in the sphere shape, but it's a half of it. So let's see if I use different color. I do my best to draw it. Okay, with this one, the metal is in the dome. So the dome part is made by the metal. And the body made with the concrete. What else that we know? The volume of the silo is 750 cubic meters. So the volume, which is the V, equals 750 cubic meters. As for the dimension, which is the radius and the height, so put in the diagram here, the radius R, the height as the H. For the sphere that sit on top of the concrete or the silo, I have the sphere would share the same radius as the radius of the silo, of the body of the silo. So this is also the R. Now from two different shapes, we're gonna find the dimensions R and H that minimize the cost of the material. So objective, minimum cost. We're gonna set up the cost function, which is the cost of the concrete, the body part of the silo. Be concrete cost plus the metal part cost. Okay, so the concrete, this one from the cylindrical shape, the metal part is from a half of the sphere or the dome, the top part of the silo. For the concrete part, this is a surface area multiplied by the the cost. It doesn't give you what exactly quantity or the price, the cost per unit area, but it just said the cost that you pay for the metal is 1.5 times the cost of the concrete. So if this is a unit 1, so this is going to be 1.5 times. Okay, we just use the overall number as whatever you pay for the concrete. The metal going to be 1.5 times. The concrete, so we look for the surface area that made by the concrete. The surface area of the cylinder. Think about how to find the surface area of the cylinder. As the surrounding part is the circumference of the base times the height. If you have the, let me see if I can demonstrate this. I have to turn on my camera, right? So you have the body of the silo, and the concrete part would be the part that's as the body of the silo. You find the surface area, actually the surrounding side here. So it looks like the thing that wrap, or the my paper towel that wrap around my bottle. And if I want to find the surface area, it's the same as I find the circumference, which is the length of the bottom of the bottle here, times the height of the silo. If I take it, I make it as this sheet of the paper, and then I want to find the area, I just open it up or cut it and unwrap it. So then it's just the rectangular shape that we have to find the area, which is the length times the width. Okay, the length times the width. And the length here is from the circumference of the circle, which is the base of the silo, or the base of the cylinder. And this, and the width here is the height of the silo. Okay, this is my quick demonstration. So then the the part here to form the surface area of the concrete would be the 2 times pi times r, which is the circumference, multiplied by the height h. And for the metal part, which is from the sphere, this is a half of the sphere. The volume of the sphere is 4 over 3 times pi times r to the third power. If you don't recall, that's fine. You can look it up. Google knows everything. And a half of the sphere, and multiply by 1.5 as the cost. Okay? It looks like many layer of it, right? So the Hermite sphere, which is uh no, that's, we don't look for the volume, sorry. It's not 4 over 3 times pi r squared. I'm wrong. So the surface area of the sphere is 4 times pi times r squared, and a half of it, because it's just a half of the whole sphere. And the cost is 1.5 times of the cost of the concrete. Therefore, the simplified form of the cost will be 2 times pi times r times h. 2 and 4 reduce. 2 and 1.5 becomes 3. So 3 pi r squared. So the cost depends on the r and the h. And how do we find the relationship? From the volume that the problem gave you as 750 cubic meters. And the volume is from the volume of the silo, the body of the silo, and the volume of the sphere. The volume of the the body of the silo here is from the base times the height, the area base times the height, which is pi r squared times the height. So this part is from the cylinder, and then plus a half of the area of the sphere, which is a half of 4 over 3 pi r to the third. Okay, it looks complicated, I know. So then we can rewrite this as pi r squared times h plus 2 over 3 pi r to the third equals 750. Pi is just involving into the thing, but just treat pi as a constant term. For the equation of the volume, you have one term that has h, but two terms has the r. It's more convenient to solve h in terms of r. So then h is 750 minus 2 over 3 pi r to the third divided by pi r squared. And this is the constraint that you're going to use it into the cost function. Okay, and then I'm going to rewrite it in the next slide with information that we have. Okay, so far we have the h equals 750 minus 2 over 3 pi r to the third. I'm going to write it by avoiding the complex fraction. So multiply by the reciprocal of the denominator. And then the cost, which is 2 times pi times r times h plus 3 pi r squared. Now I'm going to rewrite the h, or replace the h with the term that we just got from the constraint. So 2 pi r and multiply by the h, which is 750 minus 2 over 3 pi r to the third multiplied by 1 over pi r to the second plus 3 pi r squared. So this is the cost. And as you see, it's convenient to see it as pi and r can be reduced. We still have one r left. So 2 over r multiplied by 750 minus 2 over 3 times pi r to the third and then plus 3 pi r to the second. This is more complicated than the box problem because there are terms involving. Right now we have um, just clean up to get ready for the next step. So we have 1500 divided by r minus 4 over 3. If you multiply 2 over r to this term, 2 times 2, we get 4 and divided by 3, 1r and the power 3 here reduced to be pi r squared and then plus 3 pi r squared. We have like terms, so we consolidate this to be 1500 divided by r and negative 4 over 3 plus 3 as the coefficient of the same variable term, we get negative 4 plus 9, which is 5 over 3. And this number consolidated to be, did I do it right? So that's 4 over 3. That's, yep, it's going to be 5 over 3. So positive 5 over 3 times pi times r squared. Okay, 5 over 3 and pi, this is a constant term. So right now we have the function cos as the function involving the r alone. So 1500 divided by r means multiply by r to the negative first plus 5 over 3 times pi as a coefficient of r squared. So with this way we can see the power of the r individually and treat 1500 and 5 over 3 pi as a coefficient. So c prime or the derivative, the c prime of the r, c prime r equals negative 1500 divided by r squared. Similar to the pattern that we saw before, plus 5 times 2, that's 10, 10 over 3 pi r as the derivative of the c. Okay, I'm gonna go to the, oops, it's already 10:25. I already got 5 extra minutes for you guys. So let me wrap this up real quick. Okay, from C prime, so we're gonna consolidate like the last time. So negative 1500 multiplied by 3 plus 10 times pi r to the third with the common denominator 3r squared. Find the critical number C prime 0, C prime undefined. The undefined case always like ignored because if r is 0, no silo. Okay, and the numerator equals 0 is from 1500 multiplied by 3 plus 10 pi r to the third equals 0. And we're going to solve for r. And quick, r take the cube root and becomes 5.23 meters. All right. And then for r is 5.23 meters, we can solve for h from the relationship that h is 750 minus 2 over 3 pi r to the third multiplied by 1 over pi r squared. I do the math for you, don't worry. Just I want you to understand the whole process and you can get practice later on.